This is the Knowledge Graph Insights podcast, episode number 17. Machine learning architects often talk about the human in the loop. Yaakov Belch thinks that when it comes to language models, the right approach is to put humans in control. Yaakov's research looks at how knowledge graphs and large language models can help put humans in control of business contracts, capturing the actual intent that underlies them and facilitating better business decision-making based on the discoveries that they enable.
Welcome to the Knowledge Graph Insights podcast, where experts on knowledge graphs and the semantic web share their wisdom with the digital and business communities. Our mission is to demystify and democratize knowledge graph technology and practices to make the benefits of knowledge graphs and semantic technology accessible to all. And now, here's your host, Larry Swanson.
Hi, everyone. Welcome to episode number 17 of the Knowledge Graph Insights podcast. I am really delighted today to welcome to the show Yaakov Belch. Yaakov is an independent senior data scientist, and he's made this really provocative statement about, there's all this talk in the AI world in general about humans in the loop, and Yaakov says, no, we need humans in control. So Yaakov, I would love to talk about that today.
Okay. We don't need humans in the loop. We need humans in control. This is a paradigm which crystallized over time in a research which I'm doing about how to apply language models for contract understanding in a business context. So let's unpack that and see where the human control comes in. Let's say a business contract is usually a memoization, a written down expression of an agreement between two or more parties, and with intention to fulfill that agreement in the future. And it contains provisions for what different parties promise to do, rights and obligations which they have, and also some descriptions what you do if things go wrong, if there's a disagreement and so on. And after you make the agreement, you actually want to execute it. You want to fulfill it. And now very often, if you make a large contract, that different people making the contract and other people doing the work, and there's often a situation where the people who actually do the work are not really aware about what exactly has been promised, and there may be a disconnect between the expectations of the customer and the provider, based on just not being aware of what's in the huge contract, which is written in a way as a contract needs to be written, but which can't be really understood at the spot when the person needs to decide, is this promised or not? In a more complex setting or more advanced setting, you may want to understand the risks which are in the contract, not right now, but in hypothetical situations, like when you draft a contract and you want to make sure that you're not setting you up for big problems when things go in a specific way. Or you may, when you say purchase a property, you may acquire contracts which go with them, like liens and so on, that you want to make sure in your diligence work, you want to check that every liability has been properly addressed so that you don't acquire additional risks with the property, and if there are problems, you want to resolve them. So I want to understand contracts from a business perspective, and I want to use language models to understand the language. And it's not a surprise anymore that we can say language models can help with that. You can put in part of a contract, you can ask a question, you can get an answer. What is problematic, that these answers, if you don't do it right, these answers are not consistent. They're not consistent with each other. So you ask the same question, or essentially the same question, and you may get two different answers. You may get an answer which is understandable, it's justifiable, but it's not consistent with what you want, with your intention, or with your business needs. And so the system may tell you need to do something which really is against your business goals, And also it may completely be disconnected with reality, sort of that the answer which you get from a language model is not inconsistent with the world. And so the real essence of this research project is how do we deal with this inconsistency? How do we create a system where language models are part of it, and we have knowledge graphs, and we have logic, and we have humans in control to get to that business that you can rely on it for your business needs, and how we detect and how do we deal with all the mistakes which happen with language models, but also in your data you have mistakes, and how do we detect them, how do we deal with them, and that is the research. And so when I do this research, I find that you really need to be careful to use the right paradigms of what you're doing. If you just apply a playbook from machine learning or from expert systems and just try to do hard work, you may break yourself against language models being different. It's a new technology with new characteristics, and you need to adjust your paradigms of work, your goals, the structure of your work to the capabilities and the limitations or the problems of language models. And so over time, I found that one key point is to understand the right relationships that humans play in the whole scheme. It's not technology alone. It's technology, and there's a lot of people around and people involved. And we don't need people in the loop. We need people in control.
That's okay. I'm really getting we actually had a long conversation last week to set up this, and I was beginning to really get it. But that was an excellent summary of your research and the sort of the business insight and the technical challenge that comes into this. I'd love to really focus in on how knowledge graphs figure into this. Like, I'm inferring that there's a business ontology and stuff but can you talk about the specific role of knowledge graph in how you see it helping address these new paradigms that we need?
For sure, this is an excellent question, especially in the audience of the Knowledge Graph Conference and Knowledge Graph Podcast. I suggest, however, that before we talk about the knowledge graphs, which is basically a technology which supports the work, to first understand what does it really means human in control, how does it work, what do we want to achieve, what is the goal, and also how we deal in the right way with language models and understand not just that they're not making random mistakes. They're answering in an inconsistent way with what you want, and understand that a bit deeper as a goal of what problems you want to solve. And then we will see how knowledge graphs and logic play an important role. So maybe we go into 3 steps and get the knowledge graphs at the end.
That sounds perfect, because it's that makes knowledge graph the culmination, which is what we're looking for. I mean, it's a knowledge graph podcast, but no, but so I guess the first thing you said is like, what does that really mean? Humans in control? I guess I'd love to hear those three steps you just mentioned. Yeah.
Okay, humans in control. When you have a machine learning system, you're aware of that you need training data, and when you get incorrect results, one common response is to try to double check with the human in a loop and create that training data that hopefully would make your model more precise. And this usually doesn't work. It works only when you do it right, when you actually do this human in control setting in addition to humans in the loop. And you will find, if you don't do it right, that the people who you work with either don't know the right answers because they are not the experts, or they don't want to answer your question because you just overload them with repetitive work, which is not their job. But when we deal with large language models, we don't need to create training data for a language model. We need to give the language model the right context. We need to give the language model the right instructions what to do, and we need to decompose the problems into the right small pieces in order to have explainability, in order to get a handle about when and how things go wrong. And that's a different challenge. So how does human in control work? Let's give an example. Let's say you get a custom request to do some additional work. Say you have a licensing agreement with the customer, and it includes support. Now, and you think you have a clear picture of what kind of support you give to your customers. Now you get a customer who does something out of the normal, something new with your technology, and he wants your support for his new innovation, something which you didn't really think of when you created your licensed technology. How do you respond? How should you respond? Now, if you promised him this kind of support in your contract, you have to supply. If not, what do you do? And I want to create a system which helps you to make this decision, to come up with, yes, so we have a field engineer, and now he has to decide yes or not, or how to respond to the customer. And there are two answers. One answer is no, that's not part of the contract, or no, we don't usually do this. We don't support you or your. But the answer, yes, it's a new problem. Tell me about the problem. We get right into it. Now, this decision is not a decision for a language model, and it's not a decision for a data scientist. It is a business decision. Let me explain that. You can have one business which makes high profit out of scale and low costs. So they have a product, and they sell the same product to many customers. And every special request is a burden, which you need to reduce in order to get to the low cost, in order to make a profit. You have to streamline your customers as you streamline your business. On the other hand, you have service companies, or you may have a product company which a new product, which is still needs development. And then when you get a customer which points that your product may have a new use case, may have a new potential to create additional value, you see this as an opportunity. You want to jump on it. And if your lawyer would tell you, you don't need to provide the support, you don't need to get into that opportunity, you didn't promise it, don't do it, you don't listen to the lawyer. You make a decision. Our business, this is what we want to get into. So the decision about how to respond to this customer really depends on the business decision which maybe the CEO of your company makes, or which the CEO of the company makes and delegates the details to somebody else. So he says, this is a service product. We want to develop it, and we want to reach into as much as possible applications of it. Or this is a product. We want to streamline it, or maybe even we want to phase it out of the market in order to propose different products which are newer. And this decision, if your system does not connect with the intent of the CEO in this case, or on the right person in the organization which makes a decision, if you don't connect to it, you cannot make the right decision. Whether it's a human which is not connected, or whether it's a language model which is not connected, or whether it's a data scientist which guesses what is the right answer, if you don't connect, you make a wrong decision which damages your business relationship with the customer, which damages your business, and you want to have the CEO in control. The CEO says, this is what we want, and this is what we do. Now, you get requirements over here. You cannot put the CEO or his intermediate manager into the loop that he double checks every contract. You must take a feedback, and you must to accumulate and actually articulate the right problem. What's the real problem over here? And you need to articulate in a way that the decision maker, the right decision maker, can make the right decision. And you may want to gather information from many clients before you make this decision. You may want to work with past data. You want to compare similar situations with other people in the market, and give the decision maker the right background to make a decision, and let him make the decision in the way how he thinks. Not necessarily as a one-by-one yes/no decision, or by a rule in a specific rule language. You have to connect with the brain how the decision maker makes his decision, and you have to capture this and put it into the system. And this is what organizations do manually. And now we want with language models we can get into this to involve computers to make that process more efficient and also more clear. So the idea.
I was just going to say that. So the mechanism there's a lot going on in there and it's sort of like the ultimate goal being like, to support the overarching strategy and goals of the business. But that, especially that, and you were just getting to, and that's kind of what I'd love to elaborate on a little bit, that kind of, it sounds like knowledge capture, good old fashioned like knowledge management and ontology design, kind of capturing not just subject matter expertise, but capturing business intent in some way so that you can do more with it. Is that the point?
That's half of it. It's really a two-way conversation, but capturing the real intent of the decision maker is really one important half. The other important half is to ask the right questions to the right person, to prompt from the decision maker the right insights, the right question, which comes from your data. So once you have data, you have user interactions, and you get this request which nobody thought of before, so you have to bring it to the right person in the right way and prompt for the right answer. And what actually happens is when you develop a system like this, initially, you have a lot of questions to the decision maker. He's teaching you what's important to him, how he thinks, how he wants and should be engaged with the system that is a smooth operation. So you learn from the decision maker, you capture from him. But because you capture the information in the right way, you won't ask the same question over and over again. And you will get to a point where most of the things which you can learn now and what the decision maker, the expert can teach you are answered already. And so the involvement, even the amount of his involvement will decline over the amount of his connection will be less and less over time. Even if your applications to customers grow over time, so that you get more customers, you get more requests, they're automatically answered. But one thing which happens now is that instead of the expert teaching you what he knows from his past experience, he now starts to learn because he gets exposed to all of these new things which happen in his field of expertise and happen in real time with real customers, and he may not yet be aware of, or there may be small problems or important problems which just haven't come up before, but now that they need to be decided by this engine. And the engine says, I don't know. I have to ask the expert. He gets actually a real-time curated insights in what's new, what's happening in the market. And you see it as a flip, where it's initially the expert is teaching and he's providing value, and then the expert is gaining value because he strengthens his expertise in actually being connected to what's going on. And so there's two parts of it. It's conversation, and maybe when you talk about knowledge graphs, there comes another element of conversation which between the experts, which we get to in a few steps.
Okay, yeah, I would love to get to that. But you said, it sounds like what you're beginning to talk about, that's really intriguing, that like, you're talking about prompting to get the right, it's like asking the right questions to get the right answers. And that's kind of an accumulation of business intelligence is building through this process. But then you talked earlier about like, kind of dealing with the inconsistent nature of LLMs. Is that, what you just said sounded a little bit like kind of prompt engineering and tailoring your prompts to get better answers. Can you do that systematically? Is that what's going on there?
Okay, I was making a bit pun of the words when I said I prompt the expert with the right question to get his answer, and there is a similarity, and which we can get right now, between prompting human experts and prompting the network, the language model. And so let's speak about what's the right relationship to think about inconsistent answers, wrong answers from language models. Now you may realize that I very much try to avoid the word hallucinate. Why? Because I think at the moment when I say that word, put the blame on the language model, say the language model made the mistake. It made up something, and I just use a standard word for it, that this is something probabilistic which can happen. I am not doing my responsibility here. As a prompt engineer, as a system engineer, I have a responsibility to deal with these problems, and I need to take a responsibility. And if I blame the language model, I just have given up. So I try never to say that word. If you say, well, the language model makes up some word, the language model gives a right answer to wrong question, this always gives me a way to say, if it makes up information, I know I have to provide it the right information. If it gives the right answer to wrong question, I have to clarify my question. If the language model is overwhelmed that it answers the wrong part of the question, it ignores a part of my question, I need to break things down into smaller pieces. This is a part now where it gets technical. We are now the CEO and the business people can tune out of the talk, and engineers want to tune in. How do I decompose? How do I deal with language model errors? And that's a paradigm which helps me a lot. And the paradigm is called anthropomorphism, like looking at language model like a human organization. And there is a wrong way to do that, and there's a right way to do that. Let me say the wrong way is to say, you know what, a human has two hands, 2 legs, and he needs to sleep and eat. So for sure, if we think of the language model as something human-like, then for sure also needs 2 legs, and he needs to eat and to sleep, which is the wrong way. And you can even say, well, he needs eyes and he needs a mouth, which doesn't really capture what's going on over here, which is a wrong way of drawing conclusions from comparing language models to human organizations. That's the right way. Let me take an example. We have a statement, the White House says that it's important to do something. What does it mean the White House says something? That's a clear understanding. The clear understanding is there's an organization which is led and controlled by the President of the United States, and this organization has rules and problems, political problems, biases, but you have an organization, and there's a person which speaks on behalf of that organization, an opinion which apparently should be in line with the decision of President of the United States. So the White House says something, it means there's an organization which has a human in there which speaks. So it's not surprising that it has a capability of speech. What is interesting is that the speech of the White House is a mixture of many people involved. And you could even say that the president himself is an organization. Many of the themes and words which he's saying is actually written by other people, and he's just connecting them in the right way to create his this messaging. So we have a human organization. Now, when you look at language models, you see that their training data is written by real human people, and the answers which they provide to your questions are really a combination of those answers which are written by real people. And the value statement, the values which go into selecting which answer should be preferred are influenced by humans making decisions about the fine-tuning of the language model. And if you look just at this GPU or just at the technical part and you think, well, there's something coming out of it. No, there are people, real people, who have real interests, and they create that training data, they create that value structure, which in the end, which you get out. Let me say another example over here where connect this to legal thought. In legal terms, you have the idea of a legal person, which can be an organization. Sort of in legal system, if you talk about contracts, you almost never say that this is just a person. You have a legal person which can be represented in different ways by an organization. Now, this can be a one-person organization. And then you have a legal entity, which may be this organization without the people. So if you say a trust is powered by trustee, but it's a thing which exists independently even if you exchange the trustees. And you could say language model is like a trust. It's like a GPU, but it's really powered intellectually by real people. And you need to understand what these real people want, what these people do, in order to react correctly to this. So for instance, when you know that a certain question has different angles how people relate to it. You have experts which look at it in one way, and you have the different decisions, like you have common law and civil law, and you have different ways to answer the same question. and they are both presented in the input data of your system, you must be prepared that you get an answer from here or from there, unless you specify in your prompt what system you want. So if you don't provide, so if you can understand, if you think about how the insiders of this kind of question, how they think about it, what kind of doubts do they have, what kind of options do they have, and you need to provide the information what you want to guide the language model to give you the answer which you need to be consistent with your goals. Or if you leave out that information, the language model will make up. It will guess for you, and if you leave out factual information, then it will guess reality, that's what many people call making things up. Or this one word which I don't use anymore. So, and analyzing, and this is work with subject matter experts, analyzing how really the right person to answer the question, how he thinks about which language does he use, makes a huge difference in getting the right response from the language model. But that's one aspect of it here. There are many other more technical aspects, like how to understand when you need to break it down complicated questions into smaller pieces, how to make things explainable. Let's not go into this right now, but this paradigm of understanding things as a human organization, what it is, to point to real people, makes a huge difference in understanding and dealing with misunderstandings.
I love that notion of anthropomorphism as the foundation. Well, I guess if you're talking about humans in control, it's like you got to understand them correctly and kind of use metaphors and analogies about them in the right way in this whole technical and business infrastructure that you're talking about. I think that's fascinating. And I would love, are there other, when we talked last week, you mentioned paradigms. I think you said that we're coming close to time, but I wonder if you can summarize like the kind of paradigm shifts we need to make in our brains to support this kind of business insight you're talking about.
Well, there are paradigms which deal with how to present your thing to the business partners and how to think about the right places people in the role, and relating to those the big things already mentioned so far. Then there are more technical paradigms which also, some of them come out with of re-evaluations of the role of the humans, and then you have many technical details which you want to get right. So let me maybe dive a bit into your question about knowledge graphs. How does this apply to knowledge graphs? What has changed with knowledge graphs? When you think about a contract, you see that if you really read a contract, you see that it's very structured information. You have obligations, you have parties, you have rights, and you have relationships that are explicitly stated to other documents and organizations. So the lawyer who writes the contract really puts a lot of emphasis on this to make this a really structured piece of information. And there's an interesting question how to capture the structure in a way that a computer can actually analyze it and make it into a graph to deal with it. Now, when you today speak about knowledge graphs, the real question or the real interest is not really how to capture the information as a graph, that you have a graph of cells, but what do you do with that? What is the logic that you use? What are the inferences which you take? And a common mistake, I think, is that people say, well, I have a graph engine, I have a graph database, and it has some reasoning capabilities. When I speak about reasoning, it must be that I use a logic which is just hardwired into my engine, and I have to find a way how to make everybody use correctly this kind of logic. And this is a mistake because there are different, like if you study mathematics, you see that different types of logic which have different purposes, and you need to use the right logic for the right purpose. For instance, so you have predicate logic, which is often hardwired into systems, and it is driving its amplification. If you have correct axioms, you derive more correct answers, more correct statements from few axioms. So you amplify what you know. Now, if you have an incorrect axiom, or if you have an incorrect piece of information, so then you amplify that incorrect statement and you get many incorrect statements as a result. So this is the power of predicate logic. And it's one reason why mathematicians are careful how you use predicate logic, because you know that you have to be. It has a specific realm of application. Now, what we're really interested in is that the real world has inconsistencies. They are there, and the language model is adding to that. So we have inconsistent answers from language models, and we need to detect them. So we need to say we capture the messy world in some way. We find out where are things inconsistent, and then we try to ask a question and answer, how do we correct this? And this is predicate logic is not really helping us for that. Now there's another piece of technology which like Shackle, where he says detect violations of the expectations we have and reject them, which is closer to what we want. We detect inconsistency and we reject them, but really we don't need to. We don't want to reject them. We want to manage and handle them to refine the output. So we need actually a paradigm of capturing in the same knowledge graph and the same data structure different versions of reality, of different views of different people, and comparing them to find out what do we need to deal with. And if you're a programmer, you know Git, and this is a good example that before Git, people said you want only forking a project is a 4-letter word. So you don't fork because you break the attention of people into smaller projects. But once you have Git and you have ways to compare different branches and you have ways to reconcile them and to merge them, then everything that you do is you make a fork. You don't change any project anymore. You make a fork, you make a change then, and you merge it back. And you live easily with many different versions of reality of your project. And we need to use the same paradigm for having allowing different views of the world and to handle them and to eventually get also to produce sometimes one main version which we base our decisions on.
I gotta say, I love that idea that you can use knowledge graphs, because so many ontology and knowledge graph projects start with like an attempt to capture a version of reality, but the same mechanism can be used to manage multiple versions. And I love the Git analogy. That's a fantastic. I think that's a way that I think everybody gets that model and can imagine. You're kind of overlaying it on the whole ontology and knowledge graph development process. But hey, Yaakov, I can't believe we're coming up close to time already, but I want to make sure, is there anything last before we wrap up that you want to revisit from the conversation, or just make sure that we share?
One thing which I want to look at the practical side of it. This research is aimed to actually apply to real organizations, real companies, and we are now getting to that. I have built this communication engine which connects these pieces, some contract understanding engines, and put this all together. And I'm starting to work with companies, organizations, with experts of them to see, tell me you what's important to you, and how do you interact with the system? How do you interact with other people in the same system? And I'm just now in the beginning of December start to actually make this switches on to this live. And I would like to stress something about the expectations which my customers have and should have to succeed. So one thing which is very important is that you have to make a choice whether you want to cut costs or whether you want to create new value. If you want to cut costs and leave as much as possible the same, just replace expensive people by cheap language models, you will not put people into control. It's a different story. It's a different world. But if you need to create value, for instance, getting control of the agreements which you have at the right time, then you have the right setting to make the changes about how people communicate through technology. And you may end up with a situation which also saves you a lot of money. But the right approach over here is to identify a way to create new value. which motivates change. A second point already explains the expectations that initially the experts will contribute their knowledge to the system to connect with it in the right way. And after some kind of a tipping point, you will actually learn from the system what's new, what's exciting, and you will, as expert, will benefit from it. And you have to know that this is what's going to happen. A third point, which relates to this, we need relevant real data to push off this process. So that we need contracts which are relevant to you. We need real business scenarios to start this whole process of conversation between the expert and with the model, and to get to that tipping point fast, so that we don't want to wait for a lot of customers to provide this data until we get to the tipping point where the expert is connected and he benefits from the system. So these are things which customers of this kind of technology need to validate if that's what we want. Do we want to create value? Do we have, or can we get some data? Who are the people who need to be in control, and are they willing to make some changes for gaining this additional value?
Great. I love the emphasis at the start on value creation over cost cutting. I mean, both will happen, of course, but it seems like the real opportunities may lie in more creative thinking about how to do that. Hey, and I'm sure this will inspire conversation desires on the part of my listeners. If folks want to connect to you, Yaakov, what's the best way to find you online or connect?
You go to humansincontrol.ai. That is with dashes in between the words humans-in-control.ai. Go to the contact section and send me a message or an email or set up a video call.
Oh, great. Well, I'll put all that in the show notes as well. Well, thank you so much, Yaakov. I always enjoy talking with you, and this is a particularly enlightening conversation.
Thanks. The same from my side. You're a very great conversation partner.
For show notes and to sign up for our newsletter, visit our website at knowledgegraphinsights.com, and please rate and review us on your favorite podcast platform. Thank you for listening.